We are starting chapter 13 today. I don't know about you guys, but I am super excited because this is the last chapter we're doing that we have to do before the AP exam. We have some reviewing to do, and because they've changed the format of the AP exam, that reviewing is going to look a little different than I expected, but we should have plenty of time to review, so I'm really excited about that. We just have to get through this chapter and then we're done. So I wanted to review these two terms, and you can go ahead and write them down. I think these are better definitions than I gave you last time in chapter 12, because energy conservation and energy efficiency are very similar, okay? I want you to know the difference, but I don't anticipate them. I've never seen a multiple choice question asking what's the difference between energy conservation or what's an example of this. But I want you to be familiar with these two terms because they are a little confusing, but they are very similar. So to conserve energy, to keep, to save, that's what conserve means. That's changing your behaviors to use less energy. So maybe you turn off the faucet when you're brushing your teeth. You lower the thermostat so you're not using as much energy. You turn off the lights. You decide to carpool instead of, driving your own car. You decide to walk or bike instead of driving in a car. So conserving energy is all about your habits. Like, what can you do in your habits to make sure you use less energy? Energy efficiency, that's talking about using technology to use less energy, but still do the same thing. So in energy conservation, we're doing something different. We're changing the way we're doing things. In energy efficiency, we're still doing the same thing, but we have technology that makes it use less energy. So your refrigerator, they've made it more efficient by using better technology so that you lose less energy to heat and you're able to consume less energy in order to produce the same refrigeration. Light bulbs, okay, different types of light bulbs use less energy, but they're still providing light. We have a formula for energy efficiency. It's the amount of energy that comes out over the amount of energy we put in times 100, and usually we get that as a percentage, okay? Remember, nothing is 100% efficient because of the second law of thermodynamics, meaning every time we change energy forms, it loses its ability to do work. So here I have energy conservation. Some of this is a little energy efficiency here, but I want you to take a second, go ahead and you can either pause this or you can keep listening to me, but write down some of these things. What are some things that you can do in your home to conserve electricity or to conserve energy? So one of the things on the AP exam this year that they ask about is what are some solutions to some problems, right? We need to figure out solutions. These are really good examples of some solutions to saving energy or using less energy. So this is one of the reasons why I want us to focus on this and to write some of these things down. So we'll go over a couple of them. Insulation. Why would we want insulation? Well, it's going to prevent heat from escaping our house, so we don't need to use as much electricity to heat our house. If we had really crappy insulation, we would have to run the heat a lot more because a lot of that heat would be escaping. Windows. Why do we want to check our windows? Well, you would want your windows to be sealed. You'd also want them to be double pane windows, right? Having 2 layers of glass, because all of that's going to help keep that heat or the air conditioning in the summer in. Oh, motion sensor lights, right? So these are only going to turn on when somebody's there. They're not going to be left on. Caulk around your doors, again, to prevent heat or air conditioning from escaping. Replace your appliances, okay, so that they're more energy efficient. Wash your laundry in cold water. Why does that take less energy? Well, we don't have to heat the water up. Thermostats. Thermostats are super efficient. They're way more efficient than trying to control the temperature manually. And the reason is because if you can keep your house at around the same temperature, it actually takes less heat than if you were to let it go down to 60 and then let it go up to 80 and all over the place. And then use LED or CFL, compact fluorescent light bulbs. So these are all things that we can do to create a sustainable building that is energy efficient. So here's an example. This is an example of energy efficiency. These are all doing the same things. They just have different technology. So we have our incandescent bulb. Those are our regular bulbs. You can see it costs $12 to operate because it's using 60 watts of light bulb, or 60 watts of energy, sorry. It has a brightness of 800 lumens. Notice all of these have the same brightness. They're emitting the same amount of light. The only difference is the amount of energy that they're using, right? Here's an LED, here's a CFL. So you can see that with energy efficiency, we're just changing the technology. We have better technology over here and here that's able to give us that same amount of light for less energy. So in your note packet, here's what I want you to do. I made this chart. Okay, what makes a building green or sustainable? So sustainable building design. Again, this is part of our solutions that we're looking at because one of the things on the AP exam talks about, can you design a solution to a problem? Okay, so I'm going to have you click on the, there's a link and you'll pull up this picture. Okay, you might have to zoom in a little bit to read the captions. But what I want you to do is write down what are some of the elements or some of the things that make it green or sustainable, and then how does that help? And you might have to do some thinking on this one. It might not tell you directly, but for example, I wrote down rainwater collection on the roof. So we take a look over here. It says rainwater harvesting on the roof can collect water to be used to flush toilets. So how does that help if we collect water on the roof? Well, we don't have to use much water for toilets, okay? So I want you to fill in this chart. This is like a chart of solutions on how to make buildings more sustainable. I'm not going to go through all of these. You can click on that, or you can just pause it right here and kind of zoom in, or you can click on the better link that I have in Classroom. All right, so we're going to go on to renewable and non-renewable energy. So we'll do some notes on this. And we're not going to do a ton, but we'll do a little bit. So I wanted to review, a lot of times on the multiple choice, and I know you don't have multiple choice this year, but a lot of times they like to ask, like, what is a renewable, which of these is not a renewable source of energy, or which of these is a non-renewable source? So renewable energy examples, go ahead and write these down. We've got solar energy, so that's the sun. Biomass, that's plants. Plants are renewable because we can plant them and they've got seeds and they can reproduce. Hydropower or hydroelectric, that's water, okay? Usually we think of this as like dams. Geothermal, that's heat from under the ground. And then wind energy. So those are all renewable. Non-renewable is what we talked about in the last chapter. Any types of fossil fuels, so whether that's petroleum or natural gas or oil or coal. We do have coal over here. Natural gas and then nuclear. Remember we talked about nuclear power? The reason nuclear power is non-renewable, remember nuclear comes from uranium, okay? And they put this uranium in these rods. Well, think of it as like little popcorn pieces in these little rods. These are all the little uranium atoms, these little popcorn pieces. If we have popcorn, we put it in the microwave, eventually all those kernels are going to be popped. That's kind of what happens here with the uranium. Eventually all of the atoms are going to be split. Remember, we get the energy from splitting the atoms. And when that happens, it usually takes about 10 years. Then we run out of energy. We have to dispose of this whole rod and we have to insert a new one. So nuclear energy is non-renewable. If we take a look at energy use in the US, just for fun, we see that non-renewable energy is 93%. So not that great. We're only using 7% renewable. But our graphs in last chapter showed us that renewable energy is increasing, okay? So if we take a look at this renewable energy, what kinds of things are we using? biomass. So a lot of that you might have heard of, like ethanol or biodiesel. Those are examples of biomass. We'll talk about that. Dams, so hydroelectric, wind, and then solar is really small, geothermal is really small. I should probably update this figure. It's like 7 years old, so might be changed a little bit, but just to give you a rough idea there. Just a reminder, second law of thermodynamics, it's usually always on the multiple choice AP exam. Don't know if it will be on the free response, but thought I would include it here. It says that whenever energy is converted, some is lost as heat. So there's a couple different ways of explaining this, but every time we convert from one energy form into another, we lose its ability to do work. All right, so the sun. Where do we get all of our energy? All of our energy comes from the sun. You might remember that from biology. When we talked about food webs, where does all the energy from the food web come from? It comes from the sun, okay? Now, this might be a little confusing. How does coal come from the sun? Well, if you think about it, coal, oil, natural gas, all of those came from plants and animals that decomposed in the ground. So plants and animals get their energy from the sun because animals eat plants, plants use the sun. Okay. Solar energy. Obviously, that comes directly from the sun. Wind, well, the reason we have wind is because the earth is heated unequally. Geothermal is ground, heat from the ground. Okay, we also have charcoal and wood and manure, and all of those come from plants and animals. And then the only ones that we don't really have that come from the sun are nuclear. Okay, and then we're going to talk about the ocean tides. But again, you don't need to memorize these. I just wanted to show you that the sun is the source of energy for most types of these renewable and non-renewable energy sources. All right, we're going to do biomass, and then we will wait to do the other ones till tomorrow. So what the heck is biomass? Biomass, bio is living, mass is weight. So wood, manure, charcoal, plant remains, and then biofuels. These are what we use a lot of here in the United States. So examples are ethanol. You might have heard of gasoline or E85, or you might go to the gas station and see like, oh, you know, such and such a percent ethanol. So ethanol and then biodiesel. Biomass is what they usually use in the developing world. Okay, so most of the time in these developing countries, they will use either wood, okay, they will use like manure, dried out manure patties, they might use charcoal, but they don't have fancy, you know, natural gas hookups or a lot of electricity for them to use to heat things. So instead, they are cooking and heating over an open fire. The problem with this is deforestation. I actually heard an article the other day, and they were talking about when the Native Americans were around in the United States, that the forests were actually reduced by about 50% because they were cutting down so much wood for fuel. Can cause erosion then if we have plants that are being taken out and trees. Indoor air pollution, remember we talked about in our air pollution unit, and then just deaths from inhaling all of that smoke. So the deaths are actually pretty noticeable. You can see down here per million people, so the red is higher, and you can see in these developing countries, they've got a lot more deaths from this indoor smoke. So biomass is called modern carbon instead of fossil carbon. So fossil fuels versus, you know, modern carbon. You don't really need to know this vocab word. I've never seen it on an AP exam, but just so you're aware, modern carbon is carbon that comes from these living things, and fossil fuels are more like the charcoal, oil, natural gas that take millions of years to form, okay? So this modern carbon that comes from wood and trees and animals is carbon neutral, meaning it doesn't actually change atmospheric CO2 concentrations, and I'll show you why in a second. we know that burning like oil or charcoal is going to increase the amount of CO2 in our atmosphere because this stuff's been stored underground for millions of years. If we take a look though, normally we would have CO2, it gets trapped into a plant from photosynthesis. That plant, when we burn it, then releases it back into the atmosphere. Okay, so it's a pretty quick cycle, and this is why we call it carbon neutral. The difference is that when we've got fossil fuels, those are deep down in our earth, okay? So those fossil fuels, that carbon, has not been in our atmosphere for millions of years. And so when we burn it, then we're adding it to our atmosphere, and it's not taking, or it's not fossilizing back into the ground again, because we know it takes millions of years to fossilize. So we just keep adding it and adding it and adding it. It's my beautiful drawing there. All right, so these biofuels, okay, includes biofuels. There's a lot of research that's been going on about these biofuels recently. One example is ethanol, okay? Mostly comes from corn, but what they do, let's take a look. I'll move this. Let's see here. So here's what they do. So they take corn, they grind it up, and then they separate it, and they take out the sugars. And the sugars are used to make an alcohol, ethanol. So anything that ends in OL is an alcohol. And then that can be used as fuel. Okay, so that's how they make this ethanol, is basically from these corn crops. And there's been a lot of debate about ethanol, because if we're using a whole bunch of corn then to produce fuel rather than feeding people, is that ethical? And are we going to run out of land for food and all of this stuff? Okay, biodiesel is the same type of thing, but they use oil instead. So here we're using the sugars. In biodiesel, we're using the oil. So they'll take a crop and they'll extract the oil and they'll turn it into biodiesel. So kind of just like we use oil in our engines, they're just taking oil, but it's from plants. You may have heard in the news somewhere there are cars that can run off of vegetable oil from restaurants and that kind of thing. It's kind of a similar idea. All right, so what are the pros and what are the cons? So it is renewable and it's modern carbon. It doesn't release carbon into our extra carbon into our atmosphere. The problems, though, is that it uses land for food. It's not very good at getting a lot of gas mileage, a high gas mileage, so you would have to fill up your tank more often than normal. It also takes a lot of energy, like fossil fuels, to grow and harvest crops. That's kind of what you see in this picture down here, right? It's saying ethanol saves oil and reduces pollution. But look they've got a guy spraying chemical fertilizer, and they use fuel for processing, and they're using pesticides. And so you can see there's still a lot of inputs there. So this is biomass. We're going to look at the others tomorrow, but if you haven't already, go ahead and finish that chart in your notes, and I will talk to you all tomorrow.